And thank you to everybody who stayed to the afternoon of a Friday. I understand that it's been a long day, a long couple of days. You've seen a lot of interesting talks. Hopefully, I'll be able to say something of interest. I want to thank Idis and Inga for the invitation to come. I met them in Dubai, actually, while I was talking there, and they mentioned that you're having a PyCon Lithuania. And I said, yeah, I haven't been to Lithuania. I've been to Estonia a couple of times. I actually, one of the very first developers I worked with who got me addicted to open source was a developer in Estonia named Kari Peterson. He basically used one of the early libraries that I wrote and presented a makefile, gave me a makefile improvement to it. That got kind of me really excited about sharing work, and then people would mix their work with that work and give it back, and I could then, it got me addicted to the software open source ecosystem. I have a lot of appreciation for him. I didn't meet him in person for 10 years. Finally met him in person, then finally just 4 years ago we started working together. So it's like in business. So open source is that kind of a thing where you engage with people and it's loose connections and then mixed connections and it's international and it works all over the world. And then eventually you might work together in a formal way, but usually just informal, a lot of informal work. And so I've been, since then, very interested in open source. My career started in academia and in science, and have a lot of background in medical imaging, MRI, ultrasonic systems, satellite scatterometry. I'm at root an applied mathematician who loves science and math, and I used to teach university. But through all of that, my participation in a lot of open source software led me to doing that mostly. Now, when I left academia, I had to figure out how to make a living with my family, and so I've been doing business development and business activities for the past 16 years. So kind of mixing my passions of entrepreneurship and open source has led to kind of all the activities that you're going to see some of, and you've seen some of. But ultimately, it's not alone. It's because of the work of thousands of people. And I feel as a facilitator, and definitely there's hard work you have to do yourself, and it's very lonely work sometimes. But then, at the right time, you understand that you end up doing something with a little bit of luck, something that makes a difference. So I've been using Python for a long time. My very first version of Python was 1.4.2, downloaded in 1997, and we're using it for my PhD thesis. And what I found, I stayed with it because a year later I went back and read the code I'd written a year before, and I found that I could read it, and I understood I did, which was not the experience I'd had with Perl 3 years ago, 3 years prior to that, when I wrote some Perl code to process data, then I went back and looked at it, and I had no idea what I did. It was kind of a read once, write once, read never experience. But Python, I found I had this experience of write it as a domain expert. Again, I could program in C. My first computer was a TI-994A. Timex Sinclair actually was my first one. And I wrote some BASIC, and I learned Pascal in high school, and I'd written C in college, and I knew enough to be dangerous in those languages, but I didn't know computer science. I was a scientist, electrical engineer, a physicist. That's what I cared about. So you'll often hear me talk about people that know something, that their first love is something besides programming. And Python was interesting to me because I didn't have to be this deep programmer to use it effectively. But then as I learned to program, and I could learn to program, I could make a difference for people like me. And Python became, I had that experience, several hundred other people had that experience, and we sort of started to collaborate internationally to create kind of the foundations of this emergent scientific Python ecosystem. And I'll talk a little bit about that and then kind of explain how that became the foundation for the latest innovation craze, which is now much, much more than a few volunteers around the world. And kind of the hybrid interaction between the volunteer-run community, the lots of money flowing in community and how those are interacting. I think that's still happening right now. It'll be interesting to see what evolves from that. So I've been doing, at the top is kind of the businesses and the organizations I've been a part of. I started Anaconda, at the same time started NumFocus, basically starting 2 startups at the same time. I've never lost that love of starting 2 startups at the same time. So now I have 6, because I can't just have one. But it's basically, they all have a different purpose. And then on the bottom, you see these projects. Now, I didn't write personally all these projects, but I had some hand in them, either indirectly or directly. NumPy so SciPy was my baby. I started SciPy basically as multi-pack with this little sharing code and experiencing that, and a couple other people hooked together and said, hey, let's build a library called SciPy. And NumPy is what I'm most famous for. And that I wrote NumPy to save SciPy, basically from this split that was happening. And I was a professor at the time, and it led to me not being a professor because it's hard. If you've ever been a professor, I don't know if anybody in the room is a professor, I have a tenure track position. It's gotten better, but back in that day, this is 16 years ago, 17 years ago, it was really, they wanted to write papers and get money. You know, writing open source software with your friends around the world seemed really odd to people. Like, what are you doing? That's not what you should be doing. In fact, they told me that, but I still wrote NumPy, and they said, well, maybe try again. And so I left, and I started a business since then. But I want to sort of point out that this phenomena of scientific Python, which, again, me and my 1,000 closest friends, is what I like to say, who kind of participated in making this happen. The SciPy conference series started in 21 years ago, 2002. And a lot of people see, okay, the SciPy conference series, there's been Euro SciPy, it happens every year in Austin, there's lots of people that go, it's a great conference series, actually. 10 years ago, we started the PyData conference series. It's kind of like SciPy, a lot of scientific programmers, PyData, a lot of data processing programmers, almost like SciPy was to NumPy as PyData is to Pandas, maybe. As Pandas started to emerge as a data frame, this PyData community arose. We had our first workshop at Googleplex. This is actually where the idea for Conda came from, was we were there with Guido, and I talked to Guido personally and said, Guido, and I have a similar story with when I wrote NumPy and talked to Guido and Paul Dubois about how do we make Python more accessible and merge this array problem. Guido is not he's not a mathematically aware computer scientist. I guess he's aware, but it's not his first love. He's not like a mathematician who loves science. He's a computer programmer who loves programming and is very good at writing syntax for programmers, but he's been willing to allow some of the crazy things the scientists wanted in Python. He was willing to allow complex numbers to be written. Like a lot of other computer scientists, they see complex numbers and they say, oh, that's just two doubles, why do I care? And the problem is scientists recognize, well, yeah, that's true, but if we have every single person have their own version of complex numbers, now we have a mess. Like, can we actually just standardize on one idea of a complex number? And if you've ever done, I don't know if in this audience people have used complex numbers, but if you're a signal processing person or done FFTs, like, you have to have complex numbers to make sense of it. And so they're very fundamental to a lot of algorithms. And so having them support in the language is a big deal. That's why I started using Python, because they were there. And they were there because Conrad Hinson, 3 years earlier, had basically pushed that they be there, and Guido had acknowledged and allowed it to happen. Things like, in Python, how the parentheses aren't needed to specify a tuple. Now, do you notice that? Like a tuple, you can just make with commas. Well, some of the origins of that is because the bracket notation, you can pass anything into brackets, and that then is available for the indexing operation. So if I have an object with brackets, that indexing operation, how does that, it's a little awkward if you're doing multidimensional slicing on a multidimensional array. If you have to have a tuple, you have to have parentheses, then the commas. You can do it, but it looks awkward. So they basically said, hey, can we just get rid of the parentheses and just have commas? And Guido said, yeah, we can change the parsser like that. And so that made multidimensional slicing easier, right? So you could actually think about an array and have multidimensional slicing. These are subtle things that happen very early on that is often missed. Like a lot of, maybe there's some Rust programmers in here, other programmers, they sort of do things and they miss these opportunities to make the language a little bit easier. And then more accessible to people like me who don't do programming as a first love. We do something else as a first love and need to use computers. It's actually one of the reasons Fortran is still used out there. Fortran did this early and was very attentive to the scientific community and had complex numbers and multidimensional arrays. And it seems like a lot of people kind of lost sight of that and wrote other languages that didn't do that. So fortunately, I would say the Python Steering Council and the Python community, it's not like they're experts at it, but they're willing to listen. There's more openness in the community. So that openness of the community allowed for the scientific subculture to thrive, early on especially. Now, matrix multiplier was another story. That took a lot of effort to get that in. Unfortunately, that should have happened a lot sooner, but it finally got in. But here is where we talked about packaging. And as a scientific developer, Python is not just, here's some Python code, install it. Everyone goes, oh, Python's too slow. Well, yeah, but don't use Python. Just use Python to steer your fast code that runs on GPUs, or fast C++ code, your fast native code. Like, why would I write an algorithm that's supposed to go on a GPU in Python syntax? I wouldn't do that. I've never done that, never have done that. So a lot of people, but the flip side is when I'm installing a piece of software, I have more than Python code. I have .py, I've got a des.so, I've got a Fortran code that's got to be compiled, then built. So my packaging problem is a lot harder than just shipping some Python scripts, right? And that's been true from the beginning. And so when 2012, we've been talking about, hey, the Python packaging problem is a real problem. He said, yeah, just you're gonna have to solve that yourself. We don't really care. I think you're gonna have to solve it yourself. Guido was funny. I asked him about, so what do you care about packaging? And he kind of said to me, well, I just throw it in the standard library. If I have something I want to use, I just put it in the standard library. So I guess that's a feature of owning the language. Now that's not really true anymore, but it's sort of not it's not been a concern of the creator of the language. Now it is a concern generally, and then what happened after that. So we created Conda. That's where Conda came from. Conda came from saying, well, we got to solve this ourselves. Let's solve it. And we solved it by creating a full package manager. Because you can't solve it by creating a language-specific package manager that just packages things. Now, Conda didn't help developers any. It really wasn't about creating developer tools. It was a tool for end users to create a full-on solution. Since then, more work was done, and then it's actually created more confusion, honestly. I look today, and I think the packaging problem is even worse than it was at the time that we created Conda. So that's another story. We can go into more detail later. But the movement, this is basically 10 years ago. Now it's 11 years ago, but it actually started much, much earlier in 1995. There was this matrix thread. Jim Hugonin, Jim Fulton. Jim Fulton's son actually works with me now, and I know Jim, he's a little embarrassed because he doesn't think he had much of a difference in the scientific community, but he was actually one who participated early on, communicating with people about what he thought was important. And James Hugonin currently works on Dart. He actually went to Microsoft. He wrote Numeric, the very first array object that IE built NumPy on. He wrote, and was really instrumental, and it was 1995. So that's when the movement of Python, what I call now the SciPyData community, SciPy and PyData, and the ecosystem around this community-based effort to make Python accessible to scientists so they could use it, and then domain experts and data scientists and machine learning. It started there. And then it's been a rich ecosystem with lots of conferences, lots of people, lots of participants, and that's been happening ever since, basically. So we basically have 28 years of the SciPyData community, and I started using Python in 1997, so about 2 years into this movement, I started using it, got addicted to it, got connected to it, and started to participate, basically. Just like many of you are starting to participate. I was in the same boat. I started to participate, and then said, what we can do? How do we help? What do we do together? Sometimes I was talking to Chris Latner, who's coming out with Modular, a company that's releasing Mojo. I was talking to him just this past week, and he was telling me that he talks to people and they say, well, everything's done now. There's nothing to do, everything's done. And sometimes I can feel that way. You look out and see all this work that's been done, where do I plug in? There's not enough to do. We kind of laughed a little bit because there's enormous numbers of things need to be done. There's just so many things that aren't done, so many things that are bad, that are hard, that are difficult, that aren't done. Now, in some cases, you might have to dig a little harder. It's not maybe the low-hanging fruit isn't there, it's not as easy. But, I saw here somebody had, not to call anybody out, but somebody had basically written a Rust extension for a fast API. That's now a very fast API, right? Great, awesome, that's really cool. There's a lot of new people writing Rust integrations to code. We have a lot to do, a lot that can be done. We need thriving open source communities. Every single community out there could use some help, just because the funding situation it's not thriving. My focus, my energy, what I love to see is helping open source aligned businesses succeed to support those communities. And that's actually my passion. I'll want to be doing that the rest of my life, to help sustain open source communities through these open source aligned businesses. We need software that lets experts in something besides software, so where software programming is an occasional thing, a secondary thing, still write and direct important computational resources without sacrificing too much. We still today, you write high-level code, and that's awesome. It can explain, it can fit your brain, you can think about what you're doing, but you're still giving a lot sometimes performance, unless you use a framework or a library, and that's what NumPy did, is it gave you a framework and a library to write fast code by using high-level constructs. But there's challenges there. It doesn't fit every single use case. So we still need that. There's still a lot of opportunity there to actually create that. Talk more detail about that if you're interested. I think the ability to create these live dashboards, visualizations, and connect to real-time data. And do that with code that doesn't waste resources, code that's explainable, code that's easy to understand, code that's easy to maintain. And then how do we share and reproduce these systems fluidly and easily? That's just a simple, I basically put this together in about 5 minutes of thinking. Like, we thought a little harder, we could think about even more things to do. I would say, use your curiosity and your interest, and there's something to do everywhere. And it's just a matter of, okay, how are you gonna do it? What are you gonna do? I was looking at these, this absolutely affects the AI ML movement, because right now we're experiencing this trend from the community started with a very organic, from the people, populist movement of activity in the SciPyData ecosystem to create the potential for AI and ML. Now, everybody sees the commercial application of AI and ML, and multiple companies have spent billions of dollars actually building software for this purpose. Not necessarily in Python first, they all were forced to use Python because they built it with their systems, and everyone said, where's the Python interfaces? Because of this thriving community that existed in the Python system. And so they all then, okay, here's our Python interface. Some of which was pretty rocky, like the first TensorFlow Python interface was terrible. And I hope people aren't still using that. Finally, they adopted Keras, and it's a little better. But if anybody's ever seen Java code, like a Java program write a Python API, you know what I mean. It's like no, you don't do that. You don't just pretend that Python is Java and write it the same way. That would be a terrible idea. That's what they did. And what you see is actually in this trend is, NumPy has been growing steadily because it's kind of used all over the place, even though it's being replaced, basically. It's not actually the foundation, but it's a reference array implementation. And so the API has been dominating. It's actually interesting because I sit there and watch and I look at PyTorch adopt some of the name, nuances, the name definitions we came up with, like the D-type name, for example. Like D-type was just something I pulled out of my rear end. Like I didn't, there was a type system I was building. I was like, okay, what are we gonna call it? We'll call it a D-type. And all of a sudden, everyone talks about a D-type. I'm like, okay, this probably end up somewhere in some, encyclopedia of knowledge. I'm like, oh my gosh, I should have made more effort into this. There's actually a real type, but there is a real type system in NumPy. It illustrates one of the challenges of open source communities is every open source community out there could probably use a little help, and a little knowledge, and a little documentation, a little help. I could have used somebody who had type experience coming in and coaching with the type system in Python that early. It's one of the challenges, and so it's easy to throw rocks and to complain about open source ecosystems, about the problems they have. The better thing to do is just go get involved and go communicate and go talk and offer some help. And usually you'll find a very receptive and willing group that wants to help. Now, one of the challenges, of course, is typically if you're an expert at something, you have a good career, you're in demand, you can get a lot of money, and the open source community is sort of offering nothing, but maybe validation, maybe a friend, maybe an opportunity to mentor, kind of other things besides money. Really good things, actually. It's amazing to meet people, it's amazing to create a lot of friends. But you've seen over time, NumPy continue to grow as PyTorch and TensorFlow have taken off. TensorFlow's growth grew and then it subsided. PyTorch has been growing more. I think one of the reasons for that is PyTorch is trying to basically make it more community-oriented, community-driven. It's not quite completely community-driven, but they're trying, they're moving that direction. And so you see TensorFlow ease off a little bit while PyTorch grows. They're both still used heavily. I wouldn't, if you're using TensorFlow, don't rewrite all your code, keep using TensorFlow. But my recommendation is if you are starting a new project in machine learning, I would definitely pick PyTorch, absolutely. And then if you're ambitious and want to do something really cool, then see what you can do with NumPy, CuPy, and AutoDiff, right? And see if you can do a machine learning stack with just the community-driven open source. But know that you're going to be a little bit on shaky ground. It won't be as simple and easy, especially if you're trying to scale a large language model. So we have a lot of problems. I've been talking about a little bit of these. There's major problems with the status quo, just a few. One of the things that actually personally, partly because of the history of where Conda came from and the challenges of Python packaging and the fact that since that conversation with Guido, a lot of people have jumped into the Python packaging story and the PyPA was created. And everyone knows that the Python packaging authority, the authority is a joke, right? Nobody thinks it's the authority. But yet, there are a lot of new people to Python, and so they go, oh, it's the authority. Okay, we better do what they say. And unfortunately, that's created a lot of just miscommunication and people doing things that actually aren't in their best interest. One of those is vendored binaries. What I mean by that is a wheel that contains a C++ library inside of it that's actually just snapped from another project and pulled into your dependency. It's not, now you don't have any way to track that or change it or modify it. You just literally kind of broken package dependency in a very fundamental way. Don't do that. Don't do that. It actually creates a lot of problems. It causes a lot of problems not only for you later, but also for the people who have to maintain that. I watched that happen with Numba. All of a sudden, the Numba maintainers I remember the day I went to the Numba maintainers and went, why are you shipping LLVM inside of a wheel on PyPI? Well, everyone wants it. Everyone's demanding for this install. And it costs a lot. It costs them a lot of time and effort to do that, actually. So you're taking resources that could be used elsewhere and making it harder. So that's a very very clear problem. And there's a lot of ways to, I'm not here to try to promote a single way to package. There are other solutions to this, Brew, Nix, Conan even, Conda. There are other ways to solve this problem. Just don't do this. Don't do this. Don't encourage it. Don't install Torch with pip. Sorry. I know people are telling you to do that, and that's common, but don't do it. It's hurting people. There's a heavy dependency on Python. Anybody know what Python is? Raise your hand if you know what Python is. Good, y'all know what it is. So how many people have spent any time contributing to Python? Yeah, I mean, I knew that because I've only done a little bit. But it's actually, at the heart, NumPy has a little bit of dependency on Python. It actually was Pyrex when NumPy adopted it, but it's now since Python. Pandas, scikit-learn, SciPy, there's a lot of dependency on Python. And it's good in the sense that Python was better than the handcrafted CPython API code that I wrote for NumPy. I don't recommend that either. But Python, I really like it actually. I think it's a really good tool. It's just, there's a lot of energy around compiled Python now that we ought to figure out how to merge that. So it actually is the same energy. A lot of energy on the faster CPython. Some of that needs to come to actually energy on building Python. So very underfunded. There are other examples of underfunded libraries too, but this is one that I know about particularly that maybe some of you here could actually look at and get involved with. There's a proliferation of tensors and especially data frames. There's a data frame every day. I like polars, it's awesome. But there's also VAX and there's then the array and data frame, the distributed data frames, not to mention the Spark equivalents. There is something, data.apis.org, go ahead and look at that. That is an answer. We're basically trying to build coalitions and software interfaces, agreed upon interfaces to data frames and tensors. PyTorch and TensorFlow, really cool projects, enable a ton of capability, but very complicated code bases. Actually not trivial, not only complicated, but complicated in a very in-depth way. Community, and they're not really community-driven, they're not community-based, they're differently organized. Now, PyTorch is making strides between becoming more community-driven. I know Sumit personally. We've been able to become friends, and I understand his motivations. He's a really good guy. He's actually done a lot to make Meta open source PyTorch and make it effectively available to all of us. There's tons of reliance on C++, which I think is a mistake. Unless you're careful, and you can be careful, you can write good C++ code, but unless you're careful, you get this non-modular C++ ecosystem that's really hard to manage and maintain going forward. Funding and support for open source governance, community support. It's difficult. There's an attempt to do community project management. There's lots of needs in communities besides development, documentation, facilitator of community governance conversations. There's lots of that that's needed, and it's hard enough to find funding to just code it, but we also need all this other support too. And then I would say generally not a diverse enough funding fabric for open source innovations. I'd love to see anyone know what the Gini coefficient is? It's a measure between 0 and 1 of the distribution of wealth. It's kind of like that's true for distribution of funding in open source. Who's funding open source? Where's it coming from? Is it coming from just the VC community? Is it coming from just government? Is it coming from a bunch of freelancers who are just spending their time and borrowing from their future family to try to spend money to write open source? Kind of what I did, but to hope that it makes a difference, maybe, but diversity here is really critical. So the main point of that was not to get us depressed about all that needs to be done. It's actually to say there's a ton of opportunity. everyone here could do something. There's a lot that could be done to grow and improve the situation. I'm going to go quickly through some of these slides now just to kind of illustrate some of the things for me that were happening. I was driven by curiosity, an independent need for myself. I needed to read data in medical imaging library data, DICOM format. I needed to read it into Python so I could do some processing with it. Didn't have a library to do that, so I went around, I looked on the net, and I found Michael Miller had this thing called Table.io, and Table.io, it was open source, and I could just download it. I could see the code, and it was an extension of Python, and it was all there, and I could do the very well-established cut and paste programming model, right? We complain about ChatGPT, giving us code we cut and paste. We've been doing that for a long, long time, right? As long as it's not hallucinating, and as long as it's not lying about the license, if it's just pointing us to code, that's great. We learned from that. So took his code, converted it to the way I wanted to see it, read, and then talk about documentation. Guido had written an incredible explanatory discussion of reference counting. Now, most people here who write extensions, if you use Python or use Numba, you don't have to do this anymore. But if you write C code extensions, you had to figure out how the reference count interact with reference counting, because that's how the memory model was tracked. And it was a little challenging, but once you figured out how it worked, it was pretty straightforward. So that little exercise for me led to basically a 3-year journey writing a bunch of extensions. That was basically the next 3 years were spent just writing one extension after another to link to integration libraries, optimization libraries, all kinds of stuff by hand. And then I met Pierre Peterson, who said, "Why are you doing that? Let's build an automated tool for this." He was a true computer scientist. I was just someone who banged my head against a problem and do it manually if I had to. He said, "Oh, let's write a tool," and that's how you can always tell the difference. Real computer scientists won't. They're actually sometimes they call it lazy, right? They build a tool to automate the thing. Sometimes too fast. Like, wait, I'm only going to do that twice. Why do I need to automate it? Can I just do it? And you never get it done because you have the tool to do it eventually. But Pierre helped in that case and wrote F2Py. So that led to SciPy. F2Py helped us grow SciPy quickly, and that led to Anaconda because SciPy was really a distribution of Python masquerading as a single library. And the biggest learning for me was when SciPy was released, it was a bunch of, here's a tarball on the web, go download it. And some people would, but 10 to 100 times people more would use it if they got a binary they could install. So once there was a high school student named Robert Kern that made a binary release of my libraries, many more people started to use them. So I was the first, I should make sure there's binary releases. And so that what led me to this packaging question, which ultimately led to the creation of a company that essentially makes Python easy to get, called Anaconda. NumPy, again, written to save SciPy. So every one of these had a journey. It wasn't just like random, it was a walk through my experience with what I'm trying to accomplish. And then that walk, always thinking about how do I do this with others? How do I do this in a community setting? How do I do this in a way that others can work with me on it? So I'm not, because I knew that I wouldn't necessarily have the money to keep working on it, but at least can we get people? And I think while I've not been successful getting money for NumPy, at least until recently, we've had a little bit of funding for it. All through its development, there was no money for it, but we were successful getting people excited about working on NumPy. And that's why it's still here. That's why it's still here and still used heavily, is because there are a lot of people maintaining it now. And NumPy became this array extension that merged NumArray and numeric in a way that both of those could replace both of those. There's a lot of stories I could say there. Come time me if you want to talk. But then, okay, great, NumPy exists, but it has this really cool feature. Anybody know what a ufunc is in NumPy? Raise your hand if you've heard of a ufunc, or a universal function. Not very many people. That's too bad, actually, because that's one of the key things NumPy has, is it gives you this multi-dispatch mechanism that lets you basically it's what powers, the add or the multiply or the element-by-element calculations you can do. And fewer may not understand there's an extension of that called a generalized ufunc that lets you take subarrays and do subarray calculations. So all the calculations, in fact, it would simplify the architecture of NumPy tremendously if all the calculations of NumPy were actually just generalized ufuncs. That hasn't happened yet. I think that's still on the roadmap. But the thing about them, ufuncs, generalized ufuncs, they're the core kernel of operation in NumPy. That's what gives it the power. But to make new ones, you had to write C code. Like you had to write the C extension. I wanted for a long time to say, well, gosh, if I could just express in Python syntax the basic kernel, couldn't we just construct that ufunc automatically? I wanted that for years. I wanted that just as soon as NumPy came out, I wanted it, because there was a function in NumPy called vectorize. Vectorize would take any Python function and create a ufunc for it, but it was a ufunc that's kind of like the pandas apply operator, where it gives it a Python function, you can apply it across the data frame. You can do it, but it basically just is in Python land. It takes and executes this Python function on Python data. So I have this beautiful array with unboxed integers. Like there's nothing else besides the raw integer in the data. I got that data already set up, and now and if I had code that was machine code, it could run on that data very, very quickly. But instead, I'm boxing that up into a Python object, running it through a Python interpreter, running that code, and sending it back in. And if I do that for 1,000 elements, that's no big deal. That's fast enough. But if I'm doing 10,000 or 100,000 or 1,000,000 elements, now that's way too slow, and it grows way too fast. So Numbuzz, this is the same time there was Unladen Swallow. There was all these other Python compilers that were out there. They were trying to compile all of Python, which is like, well, I don't care about that. I just want to make a part of Python compilable so I can write these generalized ufuncs. So by framing the problem, we could basically construct a compiler. And Numba came out 2012, 2013, and it did it. In fact, we could do it not only with machine code, we could create GPU code actually too. We could target with LLVM and help. We could target GPU code. So we could build very fast. And so all of a sudden Python syntax was 10,000 times faster than raw Python. Because we could do it in parallel too. So that's kind of how did I get into these projects and what we were trying to do? And so how did I fund Numba? Well, I took some investor money when we started Continuum Analytics. We invested a little bit, then we basically found funding from other sources. But ultimately, Anaconda still funds Numba effectively from product sales of what Anaconda sells. And that was the reason we started Anaconda as a company in the first place, was to create a mechanism to have funding from a company. Some of the funding from that company go to, and the products we're selling go to the open source creation. So this journey, and everybody here can start in a similar journey today. It won't happen overnight, I guarantee. And we had a lecture before about business of open source. And if your goal is to make money quickly, don't do this, right? It's not a way to get rich quick. It's not a way but it is a way to have an impact. It is a way to change the world. It is a way to make a big difference, and to do it with friends and with people you care about and you end up loving. So, but it does take patience, persistence, collaboration to get there. I didn't get tenure because I worked on NumPy and SciPy. So it was actually somewhat gratifying when a couple of years ago we had a Nature Methods paper published, which now has a lot of hits. I mean, I've got my citation index has way exploded beyond what any other paper I've been part of has achieved. So I knew what I was doing was important, but it was hard for that importance to be realized until much later. So that's kind of some of the journey of where we got to where we are. Now, basically, that's a technology journey I was on. I'm still on a tech journey, but now it's actually more around helping people. So finding tech visionaries, finding capital, finding entrepreneurship, helping find these and create these open source aligned businesses. So we've done that essentially. Anaconda and NumFocus were kind of two of the first ones. We created at the same time, and then they're now being run with their folks, and now I'm doing that with several other companies. And that's what I'm involved. That's what I'm eager to do. I'm eager to work with and eager to help. Left Anaconda, started Quansight with basically those three people shown, Matt and Elite and Ashley were with me with Peter at Anaconda, and then we split out. There's a long history and detail to that, but ultimately trying to recreate the foundations that led to Anaconda. I want to create more and more of these Anacondas. So Quansight's a consulting company. Won't go into too much detail, but we basically have a labs portion and a Quansight portion. Labs is something I'll highlight just a little bit because I think we have a venture fund, actually, whose carried interest will support labs. Every single venture fund on the planet should have the same structure. Every single venture fund on the planet that basically makes money from companies using open source should have some of the money they make from those companies succeeding funding an open source research lab. So I'm patterning that idea with Quansight Labs. And I'm in the early stages of investing in companies, and maybe in 10 years we'll have, at this point, maybe only 5 years away. We've been doing it for 5. There's going to be some proceeds from those companies we invest in, and then we'll be able to put more money into Quansight Labs. In the meantime, we sponsor Quansight Labs, and Quansight Consulting builds So Quantsite Labs, now I can finally hire people to work on NumPy, SciPy, Pandas, scikit-learn, and we have a growing team of people to do that all over the world. A lot of people in Europe. If anybody's interested here about talking to me about joining or participating with Quantsite Labs, please come talk to me. There's opportunities that are always arising. We're always looking for people very interested in making open source work. And open teams and other entities that I won't go into detail about. We'll talk to you more about it. I'll talk a little bit in a couple of seconds. If you haven't had a chance to look at the lab's annual report, go look at it. I'm really proud of what we've been able to do, just kind of show the impact we're having and the kind of efforts we're doing. So labs.quantsite.org, you can go find the annual report and read more about it. So here's a very interesting idea about how to sustain AI and ML in the future. It's something we've been experimenting with. Currently, this is on hold. It's incubating, waiting to find leaders and investors. So if you're somebody very interested in potentially getting involved in something that could be incredibly, $1 trillion opportunity essentially, but it will take 10 years to get there. This is an idea that we kind of found and discovered and have explored a little bit. What if every company in the world did what Anaconda is doing and what Quantsite's doing, what OpenTeams is doing, giving some of its ownership to the open source that it depends on? What if it was just some amount? And why would it do that? We can talk about why, and come find me if you want to talk about this. But if we could do that and set up the instrument to allow that to happen, you would solve the sustainability problem. You could then have open source emerging, and as open source gets used, the value of that, every project out there would have a market value, basically, because derived from the value of the companies that depend on it, because their value is contributing to the value of that project. So it's an experiment. It exists. It's making deals. We're holding agreements in place. We have some of these agreements in place. This needs a consistent funding vehicle. So not quite yet. I need to get a little farther down the line on my own personal ability to fund that, but to make progress. But if there's anybody out there that's interested, we have a way to do it. So what I'm doing now is basically trying to figure out how to create these open source aligned businesses and help other open source aligned businesses. Essentially, what I want to see exist, organizations that I wanted to have when I was writing NumPy and leaving academia, like what I wished had existed, so that I could have continued to develop NumPy instead of just hoping and waiting and wishing that we could get a few handouts here and there. So how do we do that? And so that's what we're doing. We're an OpenTeams global and incubator of all elements of this strategy, and I can talk in more detail with people that want about them. The one I'll say a little bit more about is Incubator. Incubator has an entrepreneur residence program. It has a fund. Basically, anybody who's interested in open source business, come and talk with us. Love to talk about how we can help you create what these open source aligned business areas are. OpenTeams Global, worldwide employment organization, effectively trying to help be a resource for anybody that has to hire and wants to hire out around the world. There's some details about that we can kind of help people manage the HR difficulties. And then I talked about in the lightning talk, the Open Source Professional Network. This is a place to kind of join, and you'll basically get an advocate who can help you in your career. OpenTeams is the one thing I mentioned in my lightning talk, but I'll put it here again. If you are somebody who cares about building better software with open source foundation for businesses, come join our network. You have to have about 2 years of experience in tech leadership, 7 years of experience in development. If you have basically that background and have an interest in talking to other people about how to build better software with open source, join the network. And we have events, you meet other OSAs, we have exclusive events. You can be a speaker at our public events, promote your product or project. Very easy, just come and join. This is one of the things we're doing. So one of the things we're trying to do is this, it's a beta project. It's something we've been experimenting on in Quantsite, and we've been doing this for data APIs, for example. I'm calling it repos. It's reimbursed enhancement proposals for open source. It's basically finding a combination between maintainers that want open source, they can define the thing they want to build, and then finding funding mechanisms. And we have at least 3 different divisions of the organizations we can talk to that proven ways to get money from those organizations to sponsor this in ways that are consistent work. So we're working on this. This is a beta project still. We'll be coming out with the website. There'll be a website that this can be organized around. Right now it's just done manually with our sales team and with conversations with open source. So it's in beta, but it's emerging this year. If you're interested, you're a maintainer that has software you want to build and you want to get funded by companies and others, let me know, and you can participate. Open Source Professional Network, join it if you want your If you're early particularly and you want to find opportunities and careers in open source, this is an initiative we're going to be continuing to support for the next several years. Finally, I want to talk just a little bit, well not finally, I have a couple more points to make. I want to talk about a couple of projects we're working on that I think are really relevant for sustainable software, because part of sustainable software is getting it. Like I said, we started Anaconda with the problem of helping people get the software they need. Today, the world is still full of that. You go to Luther, the AI, you go to GPT Neo X, and they have this complex dependency tree of getting things. And how do you actually, if I'm a company and I want to do LLM experiments, how do I do that? Maybe a lot of work, actually, just to even get a little playground to work on that. So we have kind of two answers for that. One is the playground, the other is the environment management. We need more innovation, fundamentally. Like, the tools we'll talk about are helping people innovate. We need more of it, a lot more of it. But innovation requires iteration. Fundamentally, that's a principle that I've said a bunch of times. But how quickly you cycle around this loop of experiment, evaluate, adjust will determine your innovation speed, basically. So if it takes you a bunch of time to set up your environment, and then a bunch of time to figure out what you're doing, a bunch of time to get the data, if that cycle takes years, your innovation is going to be slow. If that cycle takes months, your innovation will be slow. If that cycle takes minutes, you're going to quickly be able to iterate and get someplace quickly. So, of course, data has to be integrated each step as well. Now, most organizations have kind of essential compliance constraints, right? And it interferes with this innovation cycle because, okay, I can't just grab data from everywhere and use it. There's PID constraints, there's risk constraints. I don't own that data. There's risk if I'm using the wrong code base. How do I know I can pull this in? Large language models are complicating that because there's a license behind it. Am I able to use this legally? So one way to handle this is it's an open source reference architecture, essentially a distribution of Jupyter Hub called Nabari. Nabari.dev, it's open source. You can either use it directly and spin up, it's essentially a Terraform scripts for getting Jupyter Hub plus Dask plus Conda installed. It allows you to use infrastructure as code approach to experiment quickly with large sets of clusters, large clusters and large numbers of people working on those clusters. With integration with Dask, Argo for workflow management, ClearML. You can integrate lots of other things, Visual Studio, Jupyter Lab environments, Jitsi, video chat can be integrated. There's a lot of ways to kind of use this as a system to get your environment set up quickly. Now, many of you work in organizations that already have an environment. In that case, this doesn't have to replace it. See it as a reference architecture you can borrow from it. It's just an open source distribution of Jupyter Hub. So feel free to check it out. Most of the time when you're in this environment, you have this data science ecosystem, AI/ML tool. It's built on open source, but you've got a lot of tools. You've got PyTorch or NumPy or tools at the bottom. You've got algorithms on top. You've got plotting. You've got technique-specific. You've got domain-specific, application-specific tools on top. These tools are typically moving quickly. The latest research, especially if you're doing LLMs or AI at all, like sometimes you look at these dependency graphs, they're checking out a branch of the code every time. Lots of languages and compilers typically. It's not just Python like we talked about before. You might have Python, you have Rust these days, you have C++, you have some cases Java. Thousands of individual corporate contributors, no promise of backward compatibility. So these environments are very complex. Hard to create, hard to maintain, hard to share. This is just one example of a particular dependency tree that shows up. So when people talk about, I couldn't get this, it works on my machine, it doesn't work on yours. Well, it's because of this. It's actually hard to get everything working. And many IT departments really don't like their AI/ML data scientist group because they kind of have this. It works for me. Why can't it work for the rest of the company? Why can't we make this accessible to everybody? Anticipating what versions of projects are happening. Not all open source is the same. Lots of times, a lot of companies have allowed people to start using independent open source projects, but then you basically get this dependency tree, and then, okay, wait, is that open source project going to be around for very long? Is that who's sponsoring that one? What's the community like for this one? There actually isn't really a good story here. We've done a little work at Open Teams to create the business readiness score, we call it, the Open Teams score of projects that integrates a bunch of different facets of why an open source project might be useful. But you have these different community-driven versus company-backed open source that are out there, and kind of there's different implications for them. And then some people, containers, that's the answer. We'll just all use containers and we'll ship them around. Trouble is, for these fast-moving environments, containers work if your environments are changing maybe in the order of months. You do 2 or 3 a year. They're big and bulky, and they do help with this problem. But if you're rapidly moving, it's really hard if your environments are sort of hours and days and weeks instead of months and years. And then high performance still requires bare metal. GPU work, you can't really stick containers on top of GPUs. That's still a challenge if you're talking about high performance work. Just say no to vendor wheels. I know people are tempted to use them and it's all the rage. Just say no, it's really a problem. Conda is a package manager that works and has some best practices to make it work better. And people don't always use those best practices, and so sometimes you can have trouble using Conda too. Use an environment specification. Create and save a lock file. Keep modifying your environment specification instead of just keep pip installing or conda installing packages. So Conda Store was created essentially to be environment first tooling. So think about your environment, create the environment, ship the environment. And then the environment can be used as really a specification that can be used to create your Docker container, create your tarball, create your binary or your artifact that makes it easy for reproducibility. The environment itself is really like a text file, a metadata, a description of what you want to accomplish. So it allows for reproducibility, ease of use, and governance. What a lot of companies who look at Conda Store really like is it gives their governance need an ability to understand what's going on while not limiting their data scientists and ML researchers from getting the tools they want. They get the tools they want, but they have this ability to keep control. There's a UI with it. This is available from Conda Store. There's a Conda Store UI. You can install it. It's still a work in progress, but it's already got some valuable tools like giving you ability to fix your environment, build a Conda specification in a scalable way, and then serve those environments either via Docker files or tarballs or particularly lock files. And so that lock file enforces reproducibility. One to take away from this is basically use environments, use lock files to enable reproducibility. And Conda Store is one way to do that. Final suggestions as we explore these are just examples of what we're working on now at QuantSite that might be useful to you, that might help. Final suggestions for sustainably building on AI and open source. Get interest outside of coding, basically. I know we just spent a week or a couple of days in a programming conference, a Python conference, but I would say what's interesting about everybody that comes is the things you don't do as programming. Math or economics, being an entrepreneur. This is just for me, I have lots of interests beyond programming, not to mention my family and actually my kids and the things I like to do with them. Explore libraries. Don't be afraid just to explore new cool libraries. That's what I love about these conferences is coming and kind of seeing something new I hadn't seen before. I hope some of you here saw something you hadn't seen before too. There's a lot of good ones out there actually. It's astonishing to me. And I've been doing this for a long time. It's just amazing. It keeps exploding. A lot is out there. Be curious and dive into things. There's so much to learn about. Anybody read, if you're into C++ or compiled code and you have not read linkers and loaders, get that book, please. Understand what's happening when you build a binary and what's happening. Be curious about what's going on. Tokenomics to me are interesting. It's kind of engineering of tokens to maybe help with using distributed decision making. Posits, I think. Anybody know what posits are? These are another way to do floating point in hardware. IEEE is taking over everywhere, and it seems like it must be the way you must do open floating point. But all of a sudden, with machine learning, these large language models, we're understanding that, wait a minute, we don't need 32 bits of precision on the weights. In fact, it seems like for weights to generalize, for models to generalize, we need less dependency on exactly what the weights are. They can be varied. We only need 4 bits of information on those weights. And actually, that directly translates to the cost of inference, to whether they can be applied and put on the edge, is how do I represent how do I use the bits I have to represent the floating point number there? Posits are an interesting solution here. Now, they're not widely used. Instead, they've this B16 float thing has happened, which is kind of this half-baked thing. But I have a lot of hope that there's some really cool research here that could really help us. And I just learned today, somebody was pointing me to an analog at the edge, analog implementation of multipliers. I'll have to look that up. I don't know. I'm going to have to learn more about it. WebAssembly is actually interesting to me, I think, because it's a containerization kind of problem. Or I hope it gets people more curious about how code works. Like when you write Python, what happens? And when you think about going from the domain, I'm writing Hamilton code, like there's somebody who talked about Hamilton here. How do I write Hamilton code and have it translate to machine code that runs on my computer? So WebAssembly gives you a virtual, like a transparent virtual machine you can look at that runs in the browser, but can also run anywhere. And then of course the LLM compiler infrastructure. So be curious, dive into things, be fearless, look at things and ask questions. Participate authentically. I won't be able to go into detail about this, but there was a Sustain Summit in 2020 in Belgium, in Europe actually, and there's not much here. You can go to the Read the Docs, you can see there's a lot of good conversation that took place there. And what came out of that were people thinking, how do you actually participate with open source authentically? How do you do that? How do you recognize it? How do you know what's happening? Well, it's things like starting early. Like there's a tendency to kind of have pre-baked code that then you thrust on the community and say, hey, it's open source now. Okay, that's cool, but you didn't really allow the community to participate in the creation of that thing, right? Now, there's the caveat of, kind of we all expect that when something's available, it should be perfect. Well, it actually helps the community grow if you let it not be perfect and let people communicate, let people start to put their work into it, then they own it, and they feel ownership of it. So start early, put the community first. You have an agenda, you have something you're doing that wanted you to do it, but then listen to the community and put them first. Have transparent motivations, just explain them. Like, we all have motivations, I want to get a job, I want to do this, but at least explain your motivations instead of letting people try to guess what they might be. Enforce respectful behavior, and then end gracefully is when I thought it was interesting. I guess when you are backing away, like don't just dump it on people, like end gracefully. That's interesting. I kind of agree with those principles. I thought it was very clever. I mean, they put these together, different people I didn't know put these together, but I thought they were worth repeating and talking about. Finally, you code with the community, which means ultimately care about people more than code. Code's great, but the people are more important, and the people that you're helping with the code and the people you're working with to build the code are much more important. So to code with them, care about them, and then put your heart into working with them. And if we do that, I think we can actually build an incredible future wherever it goes, that actually we're doing it together and we're doing it in a community-centric way. Appreciate the chance to speak to you today, and if there are any questions, but I think it's getting pretty late in the day and we're probably all ready to kind of maybe go get some drinks or something. So thank you very much. It's been a pleasure.